In this video, we're going to look at how to count or determine the numbers of our different subatomic particles. So we're looking at how we can find our numbers of protons, neutrons, and electrons. There are two different places that we can get some of this information. And the first place is off our periodic table. So here's an example periodic table square. So the top number is our atomic number. And that number tells us our number of protons. So that number we can get right off the periodic table. And then in the middle of our box, we have our symbol. And then at the bottom, we have our average atomic mass. Now, this often trips people up. You cannot use the average atomic mass to determine protons, neutrons, or electrons. We're going to talk about the average atomic mass later, but you cannot use it to determine how many protons, neutrons, or electrons you have. So we're pretty much going to ignore that number for these purposes. The other symbol that you'll see is a nuclear symbol that looks something like this. So it has our symbol, same symbol, and it has two numbers. This bottom number, you might notice, is the same up here. So this is our atomic number. And that tells us still the same thing, our number of protons. This top number here is what's called our mass number. And that tells us the mass of an individual atom of this type of element. So it's different from our average atomic mass. Notice this is a whole number. Your mass number will always be a whole number. And this is equal to our number of protons plus our number of neutrons. So the mass of an atom lives entirely in the nucleus of the atom. And our nucleus is made up of our protons and our neutrons. And we're going to say our protons have a mass of 1 and our neutrons have a mass of 1. So when you add all of your protons and all of your neutrons together, that gives you the mass of your atom. And so that's what the mass number tells us. So let's go through a couple of example problems to practice this. Okay, our first example is argon, and we have 40 and 18. So remember, this 40 is our mass number, and this is our atomic number. And our atomic number tells us our number of protons. So we have 18 protons. Now, it doesn't say anything about a charge, so we're just going to assume that it is a neutral atom, which means our number of electrons is going to equal our number of protons. And then we figure out our neutrons from our mass number. So if we remember, our mass number is our protons plus our neutrons. So we can set this up like a math equation. So 40 equals 18 plus n, whatever this is. So 40 equals our protons plus our neutrons. Okay, so now we just need to subtract. So our number of neutrons is equal to 40 minus 18, which gets me 22. So I have 22 neutrons. So then if I want to check, I should be able to add my neutrons and my protons together and get my mass number. So if I add 22 plus 18, I get 40. So this atom of argon has 18 protons, 18 electrons, and 22 neutrons. Example 2 is silver. So silver is 47 and 107. So this is the mass number. This is the atomic number. And that tells us our number of protons. So we have 47 protons. Again, it doesn't say anything about it being an ion. So we're going to assume our protons and our electrons are the same. So if we have 47 protons, we have 47 electrons. And then again, same as we did up here, I'm going to take my mass number. So 107 equals my protons plus my neutrons. So if I subtract 47, my neutrons get me 60. So 107 minus 47 gets me 60. So I have 60 neutrons. Again, if I add these together, I should get my mass number. So 60 plus 47 equals 107. Example 3, let's look at lithium. So we have our mass number is 7. Our atomic number is 3. So we have 3 protons. There's nothing about this being a charge, so we have 3 electrons as well. And then if I need to figure out my number of neutrons, which I do, it's my mass number minus my number of protons, so I get 4 neutrons. So if I add these two together, I should get my mass number. Now, we're just gonna add one more step. We're gonna draw this on a Bohr model of the atom. So in the center, in my nucleus, I have my protons. So I have 3 protons, and I have 4 neutrons. And then I have 3 electrons that I need to place. The Bohr model of the atom can hold 2 electrons in the first energy level. So I'm going to draw those in, and I'm going to draw them in as dots. Okay, and I have 3 electrons total. I put 2 in my first energy level. My second energy level can hold up to 8. It doesn't have to hold 8, but it can hold up to 8 electrons. So my third electron, I'm going to put in my second energy level, because my first energy level can only hold 2. So this goes 2, 8, 18, and then if you needed to, the fourth energy level can hold 32 electrons. That's the max number it can hold. It doesn't have to have all of them, but it can hold up to that many of electrons. Okay, one last example. So this one looks a little bit different. We have oxygen. Our mass number is 16. Our atomic number is 8. So that means we have 8 protons. Now we have this number here. This indicates a charge. Now if this was neutral, we'd have 8 protons and 8 electrons. But since we have a -2 charge, we need to add 2 more electrons. And you have to think of this as backwards. If it's a negative charge, you're going to add electrons. If it's a positive charge, you're going to subtract electrons. So since this has a charge of -2, we're going to add 2 more electrons to our number of protons. So it gives us 10 total electrons. And then my neutrons, same as before, I'm going to take my mass number minus my protons. So 16 minus 8 gets me 8. And then if I wanted to draw this on a Bohr model of the atom, we have 8 protons, we have 8 neutrons, and we have 10 electrons. So I can put 2 on my first energy level, and then I have 8 more electrons, so I can put 8 more on my next energy level. 1, 2, 3, 4, 5, 6, 7, 8. And so that's what my Bohr model of the atom of this guy would look like.